All right. Good morning. I hope you all good. And today, again, we are going to start our 2 mark questions at the same manner. 3 marks also. Today only we have to start. Okay. So firstly, come and join. So here, Sahil said good morning, but I'm not finding him. So, firstly, come and join as early as possible. Before going to start our class, let us close our eyes. We'll start our class. So, by prayer, close your eyes. God, kindly provide your knowledge and wisdom to solve mathematics problems and our daily life problems. Thank you, God. All right, let's start our class. So, I think Sahil came and said, okay. Right, let's move on to our problems now. So it is now part yesterday 14th problem onwards. 14th problem I said as a homework. Let us solve from 14th. 2 mark questions now. 3 questions are there. 3 2 marks questions are there. So 2 marks, 3 questions left. So once this is completed, we'll go for 3 marks. So today our aim 2 marks, 3 questions, and 3 marks. Here or also is there, means in the 17th question 2 questions, and then 18th 2 questions, and then 19th 2 questions. Okay, so 17th, 18th, 19th we have to solve. 17, 18, 19. This is 3 here. 15, 16, 14. 14, 15, 16 problems of 2 marks. 17, 18, 19 problems of 3 marks we are going to discuss. Okay, today we have to finish that at any cost. Okay. 12th solution you want again. Where is that 12th one? Let me check. Where is our 12th one? I have to check once, then I will inform to you. Where is my 12th question? Okay, you need a 12th question solution, right? Okay, let's move on to the 12th first. Here they given 1, 1, 1, A square, B square, C square. So you can use in row operations also. At the same manner you can solve by using the properties also. So row operations are, it is what we will do. Just concentrate here clearly now. Here 1, 1, 1, ABC, and here B square, C square is there. So two methods I was previously said. So what are those two methods means? The first one, it is 1, 1, 1, ABC, then again ABC, then later again 1, 1, 1, ABC you have to solve. So anyhow that part you can solve, otherwise another method. So what is that? Row. If you want to solve this kind of questions, first you need to remember what is your RHS. A minus B, B minus C, C minus A. So you just now write here A minus, so A minus B I want, B minus C I want, and then C minus A also I want. So first what I will do, just carefully observe. So first thing here, R1 tends to R1 minus R2. So then A minus B you are going to get. And second step, R2 tends to R2 minus R3. R2 minus R3. Then B minus C you are able to get. So let's write here. So this is equal to, when you apply that, you are going to get, so first 1 R1 minus R2. 1 minus 1 you get as 0. A minus B. Next one, A square minus B square. A square minus B square. Can I write? Yes, I can write. Similarly, next one, 0, B minus C, and then B minus C into B plus C. Okay. Next, as in both, what is common, check? A minus B is common. Here B minus C is common. Common that. So let me write here A minus B into B minus C. So in first row A minus B common. In second row B minus C is common. So then what you are going to get? 0, 1, A plus B, 0, 1, B plus C, then 1 C, C square. So now here expand this, expand expand this row. What is this row? Once observe carefully here. So this column, expand column number 1. Then you are going to get for you A minus B, B minus C. This was C minus A. Hence it is proved. This is your RHS. Clear? I hope you are understood. So first you need to apply elementary operations. R1 tends to R1 minus R2. R2 is R2 minus R3. Then you get in this way. Then A minus B plus C you will get. And just this complete one row expand. So anyhow first two terms are zeros you are going to get. Only the last one you have to solve. So when you solve it you are going to get as a C minus A. So hence it is proved. Clear now? Sahil, you are understood this 12th one? If you are understood, keep thumb symbol so that let's move on to the 14th. So fastly inform to me and check whether the clarity is good or not. Fastly inform to me, Sahil, so that we'll go for next problem. If you are understood 12th one, we will go for 14th. Okay, I think Sahil kept as yes, sir. Okay, let's move on to the next then. So next one, 14th question we have to solve. 14th, what is given? So anyhow, the clarity need to come. Good manner means I won't show my face for you all. Without my face, I'm going to explain. So 14th one here, given as dy upon dx is equal to y tan x, where such that since here y is equal to 1 if x is equal to 0, this we have to solve. This is a differential equation. So first what I'll do, dy is equal to y tan x. Here dx is dividing, go to that side, multiplication. Then y upon 1 this side, go to that side, 1 upon y. 1 upon y dy is equal to tan x dx. Now by integrating, by integrating, so to integrate both sides, what it happens, integral 1 upon y dy is equal to integral tan x dx. So you know that integral 1 upon y dy is nothing but log mod y. And that is integral tan x is nothing but, you know, that log of modulus sec x. Log of modulus sec x plus c. Plus c. So now I need to find the c value. How can I find? Decide for you, y is equal to 1, x is equal to 0. Substitute here. Log y is nothing but 1. Log modulus of sec 0. Sec 0 is nothing but 1. So log 1 again 0. Here also log 1 0. So what is our C value? C value is 0 because log 1 is 0. That is equal to log of sec 0. Sec 0 is nothing but 1. So log 1 is nothing but 0 plus c. So c is equal to 0. Just substitute c is equal to 0 here. Whatever get, that is your answer. So what is that? Log y is equal to log sec x. Now log and log. So here base, it should be e. Here log base e. Here also log base e. So that log will be removed. Then y is equal to sec x. That is your final answer. Instead of this, at last you may write as y is equal to minus cos x, also correct answer only. Okay, both are correct. So y is equal to sec x if you are written, that is your correct answer. If you are understood, just keep a thumb symbol. Let's move on to the next. Okay, y is equal to sec x written. Good. So if that is done, let's move on to the 15th question. Where is Garima? Garima also not came today. Sahil, one. Okay, you just be in the live and then inform to your friends also, so that let them also come and join. So now let's move on to the next one, that is 15th question. They given as a vector is equal to 2 I cap plus 2 j cap plus 3 k cap, and then b vector is equal to minus I cap plus 2 j cap plus k cap, and then C vector is equal to they given as 3 I cap plus j cap, and said A vector plus lambda B vector is perpendicular to C vector. Find lambda. In question, what is given is, in the question they given as A vector given, B vector given, C vector given. After giving that, they said that A vector plus lambda B vector is perpendicular to the C vector, then find the value of lambda. So when two vectors are perpendicular, their dot product is equal to 0. Their dot product is equal to 0. So now what I need to write? A vector plus lambda b vector dot c vector is equal to 0. If you know this, then remaining completely is very easy. B vector is there. I want lambda b vector. So here lambda b vector is there. Na? So lambda b vector, just multiply completely with lambda minus lambda I vector plus 2 lambda j vector j cap plus lambda k cap. Correct? So after that, A vector plus lambda B vector. A vector is what? 2 I cap plus 2 j cap plus 3 k cap plus lambda B vector means what you got? Minus, plus into minus, minus lambda I cap plus 2 lambda j dot product. C vector is what? 3 I cap plus j cap is equal to 0. Now, just I caps separate minus lambda into I cap plus 2 plus 2 lambda into j cap plus 3 plus lambda into k cap dot product 3 I cap plus j cap. Whenever dot product is there, I cap need to be multiplied with I cap, j cap need to be multiplied with j cap. So what you are going to get answer? 2 minus lambda into 3. So 2 minus lambda into 3, then I cap into I cap is nothing but 1. After that, 2 plus 2 lambda, 2 plus 2 lambda, nothing is there means here 1. So next, here k cap is there, k cap not there means it is 0. 0 into any k cap, 0. So no need to solve that one. Only I cap with I cap, j cap with j cap you have to solve. Then equal to 0. Let's simplify this. So when you simplify, what you get? So 3 2s are 6 minus 3 lambda plus 2 lambda is equal to 0. 8 minus lambda is equal to 0. Lambda is equal to 8. So that is your answer. Here main important point you have to remember is, so here these two vectors are perpendicular, they given means that dot product should be equal to 0. So then if cross product equal to 0 happened, then it is parallel. Dot product equal to 0 is happened, it is perpendicular, that is 0. Then if it is cross product is there, cross product is equal to 0 happened, then it is parallel. So dot product to 0, perpendicular. Then cross product means into symbol will come. So cross product is equal to 0 comes, it is parallel to C vector. Okay. So that 15th problem, if you all understood that, just keep the thumb symbol, then we'll go for next. Okay. What this Sahil said. Until now, Sahil not given any answer for that. Firstly inform to me so that I can understand. Sahil, if you are understood, just keep the thumb symbol so that we'll go for 16th problem. Still you are solving, Sahil? So you get at last lambda is equal to 8. That is your 15th question. All right. That is about 15. Let's move on to the 16th one. So every problem I'm going to solve here only so that the clarity cannot be missed. So now next one, it is 16th problem. Very simple question is given. Probability of a solving specific problem independently A and B. So probability of A they given as half. Probability of B they given as 1 upon 3. If both try to solve the problem independently, find the probability that exactly one of them solves the problem. Exactly one of them solves the problem. This we need to do. So what to do here? First, P of A is equal to half. P of B is equal to 1 upon 3 they given. So now P of A not find and P of B not find. So you know P of A naught is nothing but 1 minus P of A. P of B naught 1 minus P of B. So now answer 1 minus 1 upon 2. Here 1 minus 1 upon 3. You get answer as half here. Here you are going to get answer as 2 upon 3. So now you got A is not going to solve is also half and B is going to solve that probability is 1 upon 3 and B is not going to solve probability is you get answer as 2 upon 3. Okay. So B is going to solve is 1 upon 3. B is not going to solve is 2. Now how to solve this problem? Observe clear. So right here exactly one of them needs to solve a problem. So exactly one of them need to solve the problem means that P of A will not solve, B will solve. So from this you observe exactly one of them only going to solve. So now P of these both are they said independent events. So whenever independent events is there, just you need to multiply. That means P of A into P of B naught plus P of what is P of A? Check there P of A. P of B naught 2 upon 3. P of A naught 1 upon 2. P of B 1 upon 3. Just multiply. 1 2s are 2 upon 2 3s are 6. 1 1s are 1 upon 2 3s are 6. So when you add this 3 upon 6, 3 ones, 3 twos. So answer is half. The problem means A will solve, B cannot solve. B will solve, but A cannot solve. So that when you add these both, you get the probability that exactly one of them needs to solve the problem. Probability is 1 upon 2. Okay, that is about problem number 16. So it is your problem number 16 and let's move on to the problem number 17. So 16 we finished. Now 17 onwards, your 3-mark questions. So each question having internal choice. Let's see how we are able to solve the problems. So now first we are going to solve our problem number 17. So problem number 17, let me write here trigonometric functions. Okay, so it is given as tan inverse root x is equal to 1 upon 2 cos inverse 1 minus x upon 1 plus x. They given, we don't want those, are just they said to prove this. So how to prove this? First thing, that let x is equal to tan square theta. What do you need to think? Let x is equal to tan theta. Okay, so after that just substitute in the RHS. Let me take RHS first. Half cos inverse 1 minus x upon 1 plus x. So that is equal to half cos inverse. So now observe clearly here everyone. So here 1 minus x is nothing but what we thought, tan square theta. Write that tan square theta upon 1 plus tan square theta. Then you may ask, you may have doubt that, sir, why we substituted only tan square theta? Means we have formula of 1 minus tan square theta upon 1 plus cos square theta is nothing but what? So if you are remember this formula, 1 minus tan square theta upon 1 plus tan square theta is equal to cos 2 theta. Whether you remembered or not, no idea. Just if you are remembered, that will be very easy. So now that is equal to half, will write cos inverse. This completely becomes as cos 2 theta. You know that cos inverse of cos theta is equal to theta. According to that formula, what can I write? Half into 2 theta. This and this get cancelled. Theta is nothing but what is here? Tan theta is root x. This implies theta is equal to tan inverse root x. So now we'll write theta, and theta is equal to tan inverse root x. That is about your LHS. Therefore, LHS is equal to RHS, hence proved. So once again, listen carefully what we done here. So here it is first, tan inverse root x is equal to half cos inverse 1 minus x upon 1 plus x they given. So you took let x is equal to tan square theta you thought, and this implies go to that side tan inverse. So theta is equal to tan inverse root x. Now RHS as it is written, wherever x is there, substituted tan square theta. Then it is 1 minus tan square theta upon 1 plus tan square theta. 1 minus tan square theta upon 1 plus tan square theta is nothing but cos 2 theta. Just substitute instead of this cos 2 theta formula. Cos inverse of cos theta is nothing but theta. So now just you write the theta plus here 2 theta is there, 2 theta, right? 2 get cancelled. Then theta is nothing but what do you know? Tan inverse root x. So written tan inverse root x, that is your LHS. Therefore, LHS is equal to RHS. Hence, it is proved. So that is about your problem number 17. Okay. So I hope you all understood. So let's move on to the 18th one. Okay, he is writing only hence proved. Okay, that's good, Sahil. Only hence proved. Complete answer right last moment. Okay, now let's move on to the same 17th question, R. 17th question, second one, which is R question. So that is, they said solve the following. Solve, they said tan inverse 1 minus x upon 1 plus x is equal to half tan inverse x. So where x is greater than 0. So this is what they given. Then how to solve this problem easily? So you already know this one, that is tan of x minus y upon 1 plus xy is equal to tan inverse x minus, this is tan inverse, okay, tan inverse x minus tan inverse y. This is one formula. According to that, let's check this part now, everyone. So here, first one, x place here, what is there? 1. So y place what is there? X, 1 minus x. So just I will substitute here. Let's check. 1 minus x upon then 1 plus. So x is nothing but 1, y is nothing but x. 1 into x is nothing but x. So from this we'll write this as tan inverse 1 minus tan inverse x. Okay. So first I'll write here whatever this part is there, that I'm going to write again. Tan inverse 1 minus x upon 1 plus x is equal to half tan inverse x. Now this value, what you found by using this formula? You found tan inverse 1 minus tan inverse x. So write tan inverse 1 minus tan inverse x is equal to half tan inverse x. Okay, here minus tan inverse x, go to that side, plus tan inverse x. So half tan inverse x plus tan inverse x. Now this part, tan inverse as it is, in tan table when 1 will come, tan pi up. So the value is tan pi upon 4. So tan 45 degrees is nothing but 1. Now tan inverse of tan theta is nothing but theta, that is pi upon 4. So this and this get cancelled, then you get as pi upon 4. Now half tan inverse x plus tan inverse x means 3 upon 2 tan inverse x. 3 upon 2 tan inverse x. So now I want only this tan inverse x. So at last I want answer as only x value I need to find out. How to do? So let me write here itself that remaining part. So here pi upon 4 is pi upon 4. 3 upon 2, go to that side, 2 upon 3. So now write 2 upon 3, that is equal to tan inverse x. 2 ones, 2 twos, pi upon 3. Tan inverse comes to here, tan. Tan pi upon 3 is equal to x. Tan pi upon 3 into 2, right? Pi upon 6. So tan pi upon 6 is nothing but tan 30 degrees. That is nothing but 1 upon root 3 is equal to x. That is your answer. Okay. All right. The Sahil is writing still in that 45 degrees. That okay. So at last, what is our final answer? X is equal to 1 upon root 3. Okay. So at last we got x is equal to 1 upon root 3. So that is about your 17th one. So let's check first still how many minutes is there to complete this period. Okay, still we have time. 35 means still 15 minutes is there. Okay, so that is about your 17th question. If you are understood, just keep that thumb symbol Sahil so that we'll go for next. So 1 upon root 3 is correct answer. So if you are understood, just keep that thumb symbol so that we'll go. So next one is 18th question. Yes, thumb symbol I got. So that let's move on to the 18th one. So 18th question, again 2 questions in this. Let's see whether we are able to complete or not. The first one, it is x power y plus y power x is equal to 1. This is already we solved. So that I don't want to solve this because already we solved in the half yearly examination. You just solve by your own. And second question in this is verify mean value theorem. So this is I don't want to do because already we solved in the half yearly examination revision time. At the same manner after half yearly examination also we solved and checked answer. So now 18th one, this as a homework. I won't solve means homework. You have to solve. Then 18th our question is this. Our question is verify mean value theorem if f of x is equal to x square minus 4x minus 3 in the interval a comma b, closed interval a comma b, where a is equal to 1, b is equal to 4. So I need to verify this satisfies your mean value theorem or not. This, if any function want to satisfy mean value theorem, it need to satisfy first three conditions, right? What is the first condition? So f of x should be differentiable, and first one it is f of x is indifferentiable, and then another one it is f of x is continuous. So now first condition, f of x is continuous. F of x is continuous, continuous at the closed interval 1 comma 4. So here f of x is continuous at the closed interval on 1 comma 4. Why it is the reason here it is, this is a polynomial. Polynomial function, automatically it is f of x is continuous and f of x is differentiable at open interval 1 comma 4, which is already we learned in your chapter number 5. I think it is continuity and differentiability. In that place we discussed any polynomial function is, if they are given polynomial function, any polynomial function is continuous at the closed interval and then differentiable at the open interval. That you should remember. So now here it is f of x is continuous at 1 comma 4 since f of x is polynomial function. Polynomial function. Then second one, f of x is differentiable. This is one theorem, okay? Differential at open interval 1 comma 4. Again reason, f of x is a polynomial function. A polynomial function. Okay? Till this understood? Two steps are done. And what is our third step? Third step it is you have to find f of b value and f of a value. Let's see. Third one, f of b value, f of a value you have to find. F of b means what is here? 4. F of a means what is here? 1. Substitute 4 in the function. So now you know that our f of x is what? X square minus 4x minus 3. So wherever x is there, substitute 4. So this equal to 4 square minus 4 into 4 minus 3. Anyhow 4 4s are 16 and 4 square also that. 16 minus 16 minus 3. These both get cancelled. You get as minus 3. And let's see here f of 1. 1 square minus 4 into 1 minus 3. Now 1 square is 1, minus 4 minus 3 minus 7. You get answer as minus 6. You found here f of b is not equal to f of a. What you found here? F of b is not equal to f of a. Whenever f of b is not equal to f of a, what we need to do? So half of the problem finished and then remaining part is left now. Let's see. Anyhow, once check how was the clarity and all. If clarity is good, then everything is good. Okay. All right. So let me solve here so that you cannot face any problem of blur. Okay. So now f of b is not equal to f of a means what is you have formula? You have formula is f dash of c is equal to f of b minus f of a upon b minus a. This is completely third step. What we are doing now? Completely third step you are solving. Now f dash of c is equal to, what is f of b? F of b means f of 4 minus f of 1. B is 4, A is 1. F of 4 place, f of 4 is minus 3, and here formula place minus, and f of 1 is now what is there in that? Minus 6. So write that minus 6. 4 minus 1 is nothing but 3. Now minus 3, minus into minus plus 6 upon 3. 6 minus 3 is nothing but 3. 3 upon 3 is nothing but 1. So at last, f dash of c you got answer as 1. F dash of c you got answer as 1. So now what I need to do is, I need to take my f of x and then I have to find f dash of x. Then I have to solve the problem. Means verification how to do here it is. First one you done, that is continuous you are written, differential you are written, and third step you done in this way and you found f dash of c. Now how you need to verify this mean value theorem? So let's check here what I am going to write first. F of x is equal to x square minus 4x plus 3. Then f dash of x means differentiate with respect to x. Then dy dx of x square is nothing but 2x. Dy dx of minus 4x is nothing but minus 4. Dy dx of 3 is nothing but, what do you get? D by dx of 3 is a constant, so that completely 0. So now f dash of c means what you get here? 2c minus 4. 2c minus 4. But already we found f dash of c is how much? 1. Just substitute here. 1 is equal to 2c minus 4. Now minus 4 comes to here, plus 4. 1 plus 4 is equal to 2c. And then what I'll do with this? 2 plus 1 plus 4, 5 is equal to 2c. Then after this, what I'll do, just carefully observe. And 2 here, it is multiplying, go to that side, division. 5 upon 2 is equal to c. 5 upon 2 is nothing but 2.5 is equal to c. And this 2.5 is belongs to this 1 comma 4 or not. Means what you need to find it is, at last you will find a c value. That c value should be belongs to this interval. So closed interval 1 comma 4 means in the 2.5 is there or not? Yes, it is belongs to that. So at last we'll write here C belongs to the 1 comma 4. Therefore, mean value theorem verified. Mean value theorem verified. I hope you all understood. So once again listen carefully. So first what you done, it is a polynomial function they given, directly that first and second step you are completed. Third step you need to find f of 4 and f of 1 we found, and that both are not equal we found. And if both are not equal, f dash of c is equal to f of b minus f of a upon b minus a. This is only your mean value theorem. So now when you are substituted that values, you got answer as 1. Now what you need to do is f of x you need to write and find f dash of x. Then wherever x is there, substitute c now, means find f dash of c from this. Already f dash of c you found as answer 1, just substitute it, find a c value, and that c value should be in between 1 comma 4. For example, here got a 6 answer, then that 6 is not belongs to in this closed interval, so that mean value theorem is not verified. If it is belongs to this closed interval, then we can say it is verified. So now here it is whichever 2.5 is there, the 2.5 is belongs to this is closed interval, belongs to 1 comma 4, therefore mean value theorem is verified. Okay, I hope you all understood that. And next question is 19th one as a homework, because it is completely integrals question. So I hope you are able to solve that. So that is homework. Thus we will finish our session, today's session here. But anyhow, I'll write that question so you complete in your home. So these both also we already solved once only, but once you can check. Find integral x plus 2 upon square root of x square plus 2x plus 3 dx. This is one, and your R question is find this also find and this also find integral 2x upon x square plus 1 into x square plus 3 into dx. So this question I was already given for you in your half yearly exam. Before also I was given unit test also I was given, and this kind problem also you know how to solve. So these both complete it as a homework. So 19th one as a homework. If you are unable to solve, then tomorrow we will solve it. Okay? Means if you are having doubt. All right, may God bless you all. So today we'll end session here itself. All right, may God bless you.